Hello A2A. So if you've already printed out the packet of notes, what I have done is revise this to make it shorter, but I've kept basically the same examples just so this video won't be so long. So we're going to start off with reviewing how to solve a system of 2 by 2 and move into then 3 by 3. So you have two methods when you are solving systems. You could use substitution. That's probably best to do when you have one variable that is already isolated or easily isolated. So I know a lot of people like to do just substitution, but elimination is best used when both equations come to you in standard form. And by that, if I finish writing this, that's like ax plus by equals c. And since those tend to be the harder ones, that's the example I'm going to do. So this first one, they're both in standard form. And what we want to do is eliminate, that's why it's called elimination, one of the variables. So I'm going to find the greatest common factor, and since 2 and 7 are going to be smaller than 6 and 8, I'm going to try and eliminate my x. So I'm going to multiply this top equation by 7, but I'm going to multiply the bottom equation by a -2. My goal is to have the same number but opposite sign, so when I add the equations together, it cancels out. So what does this give me? This gives me a negative 14x plus 42y equals 42, and below that gives me a positive 14x minus 16y equals a positive 10. And so now I can add those two equations. Notice my x's get eliminated, and when I add, this is going to give me 26y equals 52, and I can divide both sides by 26, and you get y is 2. So now all you have to do is back substitute. It does not matter which equation you plug it into. I'm going to plug it into the original first equation where we had -2 times x plus 6 times, we'll be substituting in our y. So remember we solved that y was 2. So this gives me -2x plus 12 equals 6. So -2x is a -6, which means x equals 3. And then please always write your solution as an ordered pair, because that's really what you're finding here. So 3, 2, because we always write x before y. All right, that's solving a 2 by 2. Now, what if it comes to you as a word problem? What you probably want to do is first you want to read the problem through, determine what the variables are, assign letters or variables to those concepts, and then set up your equation. So the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. And then on the second day, they took in $52 by selling 3 senior citizen and 2 child tickets. Find the price of each. So we want to assign our variables. So I'm going to let S equal the senior tickets, and C is going to equal the children or child tickets. And so let's set up our equations. So on the first day, they sold 3 senior citizen and 1 child ticket, and that sold for, they made $38. And then on the second day, they also sold 3 senior citizen, and they also sold 2 children's for $52. Now, since the senior citizens was the same, this one actually was going to solve pretty quickly, but let's go through the process anyway. So what I'm going to do is I'm going to multiply the top equation by a -1, so that I can then add these two equations together. So negative 3s minus c equals a negative 38. Here we still have our 3s plus 2c equals 52. When I add those together, it eliminates the senior citizens so that I have one children ticket equals 52 minus 38 is $14. And so then back substituting, I'm going to do it into the original equation. We had that 3 senior citizens plus 1 children's, which we now know is $14, equals 38. So 3 senior citizens equals $24. So this is going to be $8. And with these, you actually want to write your solution as a sentence. So for the price of a senior, find the price. So we know that a senior citizen ticket, senior tickets cost $8 each. And the children's tickets, child tickets, cost $14 each. And that would be a review of your 2x2s. Now solving 3x3s is really kind of one extra step because your first goal is to create a 2x2 solution, but we also want to talk about the possible type of answers you can get. Because a 3x3 is solving, if you remember back in geometry, 3 planes. Where would they intersect? So you could have just one solution, which is sort of the corner of a room. You could have infinitely many solutions, which is sort of like all the pages of a book go through the spine of the book. Or you could have no solution, which would be like having either parallel planes or 2 of the planes intersect, but not at the same place as the third. Something to look for if it's infinite is when you get something like the same line, or you get the same number like 0 equals 0. No solution is going to happen when you get something like, say, 0 equals 3, which obviously is not true. That means you have no solution. All right, okay. So in terms of strategy with these, what you want to do is you want to kind of scan down your x, y, and z's and see which variable looks like it might be the easiest to eliminate. So I'm looking for small numbers and possibly opposite signs if possible. So when I look at this, and again, this is just my opinion, you can choose any that you want, but I'm going to choose to eliminate y. And what that means is I'm going to create 2 equations in 2 unknowns, which is a 2x2, and then solve that. Now, I always like to, this is just my strategy, I kind of like to keep track of my work in case I make a mistake, which I did when I was doing my answer key. And it helped to be able to go back. So I label my equations A, B, and C, and I let myself know what I am doing. So I know I'm going to eliminate y. So initially, I'm going to just rewrite this first equation for A as it is. So negative 5x plus 3y plus 6z equals 4. But since I want to eliminate y in B, I am going to multiply, and this is why I like to keep track of what I did in case I forget to multiply everything. I want that second y to be a negative 3. So I'm going to multiply everything by a negative 3. So that's going to give me negative 3 times a negative 3. That's going to give me 9x minus 3y minus 15z equals a positive 15. So I've created 2 equations where I know I can get rid of this y. So 9 minus 5 is 4x. 6 minus 15 is minus 9z. And then 4 plus 15 is 19. So I have one equation in just x and z. I need a second equation that is just in x and z, but I have to use all three of my equations. So what I'm going to do now is I'm going to use B and C. So what I'm going to do is just rewrite C exactly as it is. I don't have to do anything to it. Plus Z. Actually, I'm going to move it over a little bit. Okay, so let's just write it right here. Negative 4x plus 2y plus z equals 13. Now to B, I'm going to write B right below it, but I want that y again to be the opposite of 2y, so I'm going to multiply everything by a negative 2. And so that's going to give me negative 3 times a negative 2 is 6x minus 2y. 5x times negative 2 minus 10z, and then negative 2 times negative 5 is a positive 10. By doing that, I'm going to eliminate that y again, because you want to stay with the same variable that you eliminate. You're trying to create a system of 2 by 2s. So here I have 6x minus 4x is 2x, z minus 10 is minus 9z equals 23. So now what I can do is I have two equations in two unknowns. So let me bring this over. I'm going to rewrite this one right below. I guess I could have brought the other one down, actually. That might keep this a little bit neater. So I'm going to write this one down here. So I have 4x minus 9z equals 19. So we kind of have a little bit of a gift here. Notice that I've got the same 9z, but I do want to have opposite. I have noticed if you add the two equations, there's less mistake than if you try and subtract, because people forget to distribute the negative. So I'm going to multiply everything here by a negative 1. So I'm multiplying everything by negative 1 and add the two equations together. So 2 minus 4 is negative 2x. Those two eliminate. 23 minus 19 is going to give me a positive 4. So we get that x is going to be negative 2. As soon as you get that first solution, it's like jackpot. All you have to do now is back substitute. So, and you don't have to go all the way back. You only go one step back. So I am going to go, let's see, probably the easiest would be right here. We had 2 times x, which we now know to be a negative 2, minus 9z equals 23. So that's negative 4. And then we add 4 to both sides. We still have a negative 9z equals 27. So z is a negative 3. And for the last equation, to get my y value, I go back to any of the original equations. I'm going to use equation b, because y is just by itself there, and plug in what I know. So I have negative 3 times a negative 2 plus the y value, plus 5 times negative 3 equals negative 5. So I have 6 plus y minus 15, and so y minus 9 equals negative 5. That's going to give me that y, when I add 9 to both sides, equals 4. And once again, you always want to write your solution as an ordered pair. So in 3 dimensions, it's x, then y, and now z. So it's going to be negative 2, 4, negative 3. Not the order you found it in, but x, y, z. All right? Now, if you would like to try this one on your own, that would be awesome. That means you should pause the video, because I'm going to go ahead with this problem. I'm going to choose to eliminate z. And I always like to write down, just because if I get in the middle of my problem, which variable was I eliminating? I'm going to eliminate z. So this was a, b, and c. So I'm going to first add a and b. That's going to give me 2x plus 2y. Oh, look at that. My z's already go away, equals 8. That's awesome. All right. Now let's bring in B and C. If I add those, I get 4x plus 4y. Oh, the z's go away, yay, equals 16. Well, let's simplify these. This one I can divide everything by 2, x plus y equals 4. And this bottom one, I can divide everything by 4, x plus y equals 4. Wow, I get the same line. If I were to subtract one from the other, I would get 0 equals 0. So what we have here is infinite solutions. Now, in the book, they're going to talk about making a relationship between each of the solutions, let one of them be a variable. We're not going to go there. If you get 0 equals 0 and want to tell me infinite solutions, we're going to go with it, okay? But just remember, if I had gotten something like 0 equals 3, that would mean you have no solution and you don't have to keep going. Just like with the infinite, you're done. That's all you need to do. Okay, let's now do a 3 by 3 word problem. Typically, not always, but a lot of times, these come to you in a very specific way. You're going to have an equation that represents a quantity of something, a value of something, and a relationship between those things. So in this one, you find $6.60 on the ground at school, back in the day when we could go to school, all in nickels, dimes, and quarters. You have twice as many quarters as dimes and 42 coins in all. How many of each type of coin do you have? Because of course you can't just count what you have in your hand. We're going to make you do the math. So to keep it easier, I'm going to keep X, Y, and Z. So we're going to let X equals nickels, Y equal dimes. Again, you always want to let us know what you're using for your variables. Z is going to be quarters. All right, so my first equation is going to be my quantity equation. How many coins do I have, regardless of the variables and how much they're worth? And that is 42 coins. So if I take the number of nickels and add it to the number of dimes and add that to the number of quarters, I have 42. My next is going to be looking at the value that goes with each coin. So I know that in total, I found $6.60. Well, each nickel is worth 5 cents. So that's 5 cents times the number of nickels tells me the quantity in terms of nickels. Each dime is worth 10 cents, and each quarter is worth 25 cents. And together, that gives me $6.60. With these ones that have to do with money, because notice you got decimals, and some people aren't big decimal fans, what I like to do is take this and multiply by, if I have 2 decimal places that I have to represent, I multiply by 100. And that's going to give me now 5x plus 10y, basically move your decimal place 2 places. 25z equals 660. So I can use that equation. It's a little friendlier because it doesn't have any decimals. Now this last one is the relationship one. This is the one everyone gets backwards. Okay, so the relationship is that I have twice as many quarters as dimes. So intuitively, we know we have twice as many. You have more quarters than you have dimes. But if I'm going to set up a relationship where they're equal, that means I have to double the number of dimes. So that if I double the number of dimes, now it's going to equal the number of quarters because I have more quarters. All right, so if you're not sure, plug in a number. If I have 10 dimes, I'm going to have 20 quarters. That's a twice as many quarters relationship. With these ones, I recommend doing substitution. And what I'm going to do is into the quantity and the value equation, I'm going to substitute this relationship and rewrite my equations. So for the quantity, I have x plus y instead of z, I'm going to write 2y. That equals 42. So we can simplify that to x plus 3y equals 42. And then for the value equation, I'm going to do the same thing. I had 5x plus 10y plus 25 times 2y, so z gets replaced with 2y equals 660, and that simplifies to 5x plus, so I have 50y plus 10y, that's going to give me 60y equals 660. So you can see how you might need a calculator. That might be handy. You can use a scientific calculator, you can use Desmos, whatever you have available to you. Okay, so I'm solving now a 2 by 2. We brought it down to that by doing our substitution. So what I think I'm going to do is I'm going to leave this equation as is, and the top equation I'm going to multiply everything by -5. And I don't really want this line right here. So let me go ahead and let's multiply everything by a -5 up above. So that gives me a -5x minus 15y, and then 5 times 42 is -210. So now I can just add these two equations together. Notice that my 5x will cancel, and so 60 minus 15 is going to be 45 dimes, and this turns into 450. Look at how friendly that is. We are talking money, so it should be whole numbers when your answer. So we get y equals 10. That's going to represent our dimes, and now again it's pay dirt. Woohoo! We just back substitute. So if I have 10 dimes and I know I have twice as many quarters, I can go 2 times 10 is 20. That's going to be how many quarters I have. And we do need to figure out the nickels, so I would probably go back to the original, which is the easiest. So I have so many nickels plus 10 dimes, 20 quarters equals 42 coins. So x is going to equal 12. And again, when it is a word problem, you should express your solution in writing. So I have 12 nickels, 10 dimes, and 20 quarters. All right, I hope that all made sense, and we'll do some practice with that just in a few problems on your homework, and then also tomorrow morning as well.